Hello wonderful person, this is Anton, and today we're going to be discussing a mystery of a very unusual star in the nearby Large Magellanic Cloud, a satellite galaxy of the Milky Way. And in this case, this is actually a pretty famous star, because at some point it was listed as the largest star we've ever seen. It was actually a record holder for at least a few years. And so here, this star known as Westerlund Olander Hedin G64, or WOH G64 for short, was believed to be approximately 1600 radii of the Sun in terms of size, basically putting this almost at the limit of how large stars should be able to get. But this also turns out to be an extremely unusual and even confusing object, because a lot of additional observations and accurate measurements discovered a lot of bizarre things about it, including the fact that it seems to be changing extremely quickly, with some of the more recent studies even suggesting that maybe this star is about to go supernova, and what we're observing are essentially its last moments before it finally collapses and explodes. Which actually, of course, would make this a super exciting object, as nearby supernova are generally pretty rare. And so for the past few years, astronomers have been debating about what exactly is happening here, and why the star is behaving the way it is. And so in this video, we're going to discuss some of the recent updates and some of the recent studies about WOH G64, a colossal star 160,000 light years away from us, which for many decades was considered to be a textbook example of a typical red supergiant, so basically stars like Betelgeuse. But these recent observations suggest otherwise. These dramatic changes and mysterious transformation might be telling us something incredible and something we never expected. But to understand the importance of this, let's briefly discuss the star itself and what we know about this so far. And by the way, a lot of this is once again based on several different studies you can find in the description that essentially observed the star for many years and discovered a lot of things about it. And so let's take a look at what we know about this, or at least what we thought we knew for approximately 40 years. And that's because originally this was discovered back in the 1970s. Its discoverers, Westerlund, Olander, and Hedin, basically represent the first three letters in its name. And from the beginning, this star really stood out. It seemed to be super big. Basically a red supergiant. A star with a mass of at least 10 to possibly 30 solar masses that essentially reached its final stages and was poofing up so much that it could explode in the next few thousands of years. Mostly because it already burned through all of its hydrogen and was now fusing a lot of heavier elements, which normally don't last very long. But because it was fusing heavier elements, it basically puffed up to incredible sizes. Once again, approximately 1600 times the solar radius. And to put that in perspective, if you were to place the star in the center of our own solar system, with the Sun basically being this tiny pixel right there, its surface would reach all the way to the orbit of Jupiter, swallowing all of the inner planets. Or, if you were some kind of a ray of light traveling around the star, it would actually take approximately 6 hours to go across the equator, basically even at the fastest speed in the universe. So yeah, this is a large object. But while being large and being so massive, it is relatively cold for a star. The surface temperature is approximately 3400 Kelvin, at least 2000 degrees colder than the Sun, which basically makes the star glow in a deep red. But the problem is that because it's so cold, this also creates a bit of a problem for modern theories involving stellar evolution. So here, based on a lot of models, this star surprisingly appeared to be much colder and also much more luminous than theories predicted for a typical supergiant star. As a matter of fact, based on what's known as the Hayashi limit, this star was not supposed to even exist and should not have any kind of equilibrium. And so one of the first main breakthroughs was actually from back in 2007. Here, by using the Very Large Telescope Interferometer to try to actually resolve the environment around the star, for the first time ever, researchers were able to see an actual individual star in a completely different galaxy. And they discovered that this is not just any star, it seems to be surrounded by a massive thick torus resembling a kind of a donut of dust. And this dust torus is approximately 1 light year in diameter and seems to contain anywhere from 3 to maybe even 9 solar masses of material. All of this was expelled over time, and this observation solved at least one mystery, but also created a new problem. And so first of all, by realizing that the dust here was not a simple sphere, but a torus, this allowed scientists to recalculate the star's luminosity, revealing that the radiation from the star was actually escaping through these donut holes, making the star appear much brighter than it actually was. And so the real luminosity was much lower, which suggested that the star was a lot closer to predicted theories and very likely had the initial mass of approximately 25 solar masses. But at the same time, because of this massive torus, it suggested that this star was losing mass at very extreme rates, at least one Jupiter mass every single year. And that would be the highest rate seen from any similar star, and that by itself was a bit of a problem. It was kind of difficult to explain why so much stuff was lost, or basically why exactly did it form this very massive, very bizarre donut. But something else started happening around 2014. Now for a very long time this star was believed to be a semi-regular variable star. In essence, it changes brightness every 800 days. In supergiants, this is usually pretty common. But in 2014, something changed dramatically. The regular pulsations became irregular, with some of them even being completely suppressed. And more shockingly, the entire optical spectrum actually went through some kind of a transformation. And specifically, there was one thing that was missing. For many decades, the star exhibited very strong signatures of titanium oxides. This is usually a very clear indication of a relatively cool M-type red giant that very often contains this particular molecule, but after 2014, all of this titanium oxide completely disappeared. With the study from 2014 that you can find in the description, essentially suggesting that we might be witnessing something super rare, and specifically an extremely rare transformation when a star stops being a red supergiant and instead becomes a yellow hypergiant. And in this scenario, the star sheds a massive part of its outer envelope, causing it to dramatically shrink in size, but also causing it to increase in temperature. But more importantly, yellow hypergiants are believed to be extremely short-lived and unstable, implying that if this is true, this will be basically the final super wind phase of the star, potentially preparing it for a massive supernova in the near future, very likely during our lifetimes. In other words, the study suggested that we may be witnessing an imminent supernova. And so a lot of astronomers got super excited and started to observe this object even more. But then, extremely recently in 2026, another study came out with the title "A Phoenix Rises from the Ashes," which basically once again solves one mystery, but creates a new problem as well. And so here, Jaco van Loon and Keiichi Onaka published a follow-up observation using the Southern African Large Telescope. And here they looked at the star between late 2024 and 2025, which, to their surprise, revealed titanium oxide was back. And the reason titanium oxide is so important is because it can only exist in much cooler temperatures. Its presence actually implies that the star is still a red supergiant and might have never actually transformed after all. Or basically, it has not transformed or potentially doesn't intend to transform anytime soon. And here they argue that what we saw in 2014 was not the star physically changing, but instead was a result of a binary companion. And specifically because now we seem to have more evidence that this star is not a single star, but is instead what's known as a symbiotic binary. Two very massive stars, a puffy red supergiant and a much smaller, much hotter B-type star. And so here, as the two stars orbit each other, they occasionally pass very close to one another, with the gravity from the smaller companion stretching the outer layers of the supergiant and causing them to both transform, but in some cases also releasing them to the outskirts and creating this massive torus. And here, the stretching of these layers would actually make them slightly more transparent, allowing us to see much deeper into the star's inner hot layers, which might actually explain why at some point it resembled a yellow hypergiant. So basically, it was actually just misshapen, and the outer layers became a little bit more transparent. But now that the stars are slowly moving apart again, the giant's atmosphere has settled down, and its original signatures returned as they were before. And so interestingly here, the observations from the star sort of resemble the unusual period of instability that also happened around Betelgeuse back in 2019. This was the famous dimming event that is now almost certainly explained as the result of a partner orbiting Betelgeuse. And so if all of this weirdness comes from the fact that this is a binary system, it may suggest that for many of these stars, it's really their partner that seems to often dictate what happens and whether these stars go supernova or not. But for this particular star, the companion is also stripping the supergiant of its gas, resulting in the formation of this giant donut, several solar masses in mass. And so this binary interaction one day could determine if the star goes supernova and creates a type 2 supernova, or something a lot more rare. And at the same time, these observations also solve another major issue, something referred to as a red supergiant problem. And that's because when we look at various remnants of past supernova, we almost never find any luminous red supergiants as the parent star, even though modern theories suggest that they should be the primary source of a lot of these explosions. We actually get to see what happens in these last moments, and of course get to see how these stars transform before they truly explode. And so if these stars really turn into yellow hypergiants and lose their red envelopes before the explosion, it might finally explain why we don't see any red supergiants as supernova progenitors. Which would also suggest that stars like Betelgeuse still have so much to go before they're finally able to explode. But in the end, the star still remains as a bit of a puzzle. It's still not entirely clear what's actually happening here, and we're not going to know exactly what's happening for at least some time. But what's clear is that in the next few years, the star will probably go through some kind of a different transformation, allowing astronomers to finally make certain conclusions. Although I guess based on these recent observations, it now doesn't really look like it's going to go supernova anytime soon. Nevertheless, this is still a very bizarre object just because of this massive egg-shaped cocoon that we actually have not seen in any other system so far. And so here this is a pretty good reminder that things in the universe sometimes do change pretty quickly, and even the biggest things in the universe are constantly changing. And in this case, we're just lucky enough to see this in real time. Which of course means that we'll probably come back and discuss this more in the next few months, as there are some new updates and new observations. Until then, check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon, where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.